Today we're going to be doing another optimization problem. The sum of two numbers is 60. What is the maximum product of these two numbers? And likewise for how we did in the previous one, it is always good to assume the quantities for which we're trying to solve for. And in this case, we are trying to solve for the sum of the two numbers, which I'm going to suppose number 1 to be x and number 2 to be y. So we are given that the sum of these two numbers should be 60. So I'm going to write that down as a reminder. And now I'm trying to find the maximum product of these two numbers. And to find the product is simply x times y should be equal to a maximum product. What we can do is we can use this function x plus y is equal to 60 to write x in terms of y. So x will be equal to negative y times, or rather negative y plus 60. We rearrange the equation to get x is equal to negative y plus 60, which we can then substitute for our function of m in terms of y. To get m is equal to negative y plus 60 times y, which is equal to negative y squared plus 60y. And that is equal to the m function, which is now written in terms of y to be negative y squared plus 60y. And what we can now do is take the derivative, the first derivative of the m function to obtain the critical points for maximum and minimum values. So m of y's prime will be equal to negative 2y plus 60. This is the power rule, and we're going to set this derivative to be equal to 0 because only when the number is set to 0 can we find maximum and minimum values of a function. We can rearrange this to get negative 2y is equal to negative 60, y being 30. And since we have y, we can solve for x through the equation x plus y is equal to 60, x being negative y plus 60, which is equal to negative 30 plus 60, which is equal to a grand total of 30. So y is equal to 30 and x is equal to 30. Hence, solving this problem for the optimization of the sum of two numbers being 60 and the maximum product, which is 900.